So now we're going to start on the second part of anti-inflammatory drugs. We're going to talk about NSAIDs, non-steroidal anti-inflammatory drugs. I have started on this talk a couple of times, and I've realized that I have a lot to say about these drugs. And there is a lot to be said about them because you will see them in practice. They're prescribed all the time. So you need to know about non-steroidal anti-inflammatory drugs. So one thing to know, so Rimadyl is one of the major ones that you'll see in small animal clinics. And what happened about 20 years ago was that um, more of these drugs came on the scene and they appealed directly to owners of dogs in particular because dogs get arthritis and owners have wanted things for their dogs to be the same as for them. And so there was a need out there. We did not have the best drugs before these drugs came on the scene. Um, and Rimadyl was really one of the first ones. It had been used in Europe, and then it got FDA approval over here from Pfizer. Pfizer is now Zoetis. You'll see drug companies change their names a lot. I think they split up different parts of them, and Pfizer is a human drug company, and so they split off their animal drugs into a different name. And I don't know all the reasons for these things. It probably has to do with economics in some way, shape, or form. But there are a variety of these drugs, and just like if I did a little survey in class about which drug do you reach for when you have a headache or you have a minor ache and pain, I would probably get a bunch of different answers. And the fact is that certain drugs will work in certain animals well and not in others as well. Just like you may want to use arthritis for a headache, and I might think ibuprofen's a better drug. It just, if one doesn't work in an animal, sometimes we try a different one. Also, there's some different advantages with the forms that they take. So anyway, we're going to start talking about them. And we need to talk about the arachidonic acid inflammatory pathway again. So if you remember, corticosteroids act up here right at the beginning of tissue injury where phospholipase is released. And that enzyme combines with, it forms um, arachidonic acid, which then is acted upon by cyclooxygenase and lipoxygenase. And these are abbreviated as COX and LOX. We're going to mostly talk about this side of the cascade. That's not to say that this doesn't play a part, but it does not seem to be as much of the inflammatory mediators that work, or we haven't found mechanisms to act on it as well. But some of these NSAIDs do act on that side. So on this side of the cascade, cyclooxygenase uh, leads to prostaglandin formation and thromboxanes. And then on this side, the lipoxygenase, the LOX, acts to form leukotrienes. And all of these are what we refer to as inflammatory mediators. They're also referred to as eicosanoids, and they lead to promoting inflammation in the body. So the thing that happened about 20 years ago that the drug companies looked at was how cyclooxygenase acted. And cyclooxygenase can be divided up into two different subenzymes. So COX-1, and this is thought to help in producing um, um, gastroprotective prostaglandins and promote renal blood flow. And COX-2 produces inflammatory prostaglandins. And so the idea was that we would like to have a drug that acted on the inflammatory producing COX enzyme, which is COX-2, and we would like to not act as much on this enzyme because this enzyme does things that maintain the lining of the GI tract. So some of those things that happen with That COX-1 enzyme is it will produce bicarbonate in the stomach, and that'll reduce the acidity of the stomach. It will promote the formation of mucus, which helps to line the stomach and protects it from the stomach acid. And it also promotes blood flow to the lining of the GI tract. And the other thing that it does is promotes renal blood flow, and we'll talk more about that and why that's important. So these NSAIDs may also inhibit lipoxygenase, but we're going to focus more on COX-1 and COX-2. Um, so they promote mild analgesia, and that's another part of the prostaglandin area. Your book goes into how this affects the signals that go to the brain and let the body know that they're in pain. And um, basically, what happens, you can read more about it in your book. Um, what happens is that when we get pain, when something induces pain in us, let's just say that we get a paper cut and we put some pressure on it and it seems to be fine, and we put a band-aid on it to stop the bleeding. And over time, though, what's happened initially is that there is a release of something called endorphins and some other pain mediators, and we get the sharp pain at first, and then it kind of dulls, and we don't notice it quite as much. But then the next day, if it's deep enough paper cut, it might be a little swollen. And if we touch it, we get more painful. And that pressure we might have used to stop the pain initially. So what happens is those pathways become more efficient in transmitting the pain. This is called wind up, when an animal starts to perceive pain and then continues to perceive it, it just gets worse. And so we would like to prevent wind up. And your book talks about that and uses that term. And there's more information about it in the section that talks about opioids in the book. And we don't cover that in this class. We're going to cover opioids. You will get that in your anesthesia class. And so the other thing that happens is allodynia, and that's a term that means that transmitters that relay sensory information, such as pressure, uh, will also respond to pain or become painful. And that's why when you put pressure on something that is swollen, it will feel more painful. And that's normally just a pressure receptor indicating to you how much pressure is on something. So what we'd like to do is get a handle on pain to begin with. And so typically we'll give um, NSAIDs, maybe an opioid in combination, because if we can give a little bit less of the opioid and do some of the pain control with NSAIDs, that's better. And they also will cover different areas of the pain pathway. And so the idea is we give it before surgery because we know we're going to induce pain. And then as the animal comes out of surgery, we'll bump up the pain medication again and send them home with pain medication. All of that is to reduce the amount of the perception of the animal pain and reduce the chances of those pain pathways ramping up and making the animal more painful. But in general, NSAIDs have a more mild analgesic, which is pain relief effect, than do opioids. So we can classify NSAIDs as two different types. So there's non-selective, where they inhibit both the COX-1 and COX-2 enzymes, and these are drugs such as aspirin, phenylbutazone, flunixin meglumine, diclofenac, ibuprofen, and naproxen. There are selective COX-2 enzymes, and this is where carprofen, which is the generic name for Rimadyl, came out um, as promoting just inhibiting the COX-2 enzymes so that it would just act on the inflammatory parts of the inflammatory mediators that were produced and not on the protective prostaglandins that protect the stomach. And these drugs are carprofen, etodolac, daracoxib, meloxicam, firocoxib, and robenacoxib. And I'm going to test you on the generic and the um, trade names of these drugs because you need to know them. They are that commonly prescribed that you will need to know both of them. So there is a box at the end of the chapter. There's also use this PowerPoint for looking about that, and I will talk more about it in class.